let's talk about how to troubleshoot a basic safety relay. And some of these are orange, some of these are yellow, but all of them are basically the same. And while we also do have configurable safety relays and safety PLCs, which we're going to cover, I believe that understanding this basic safety relay will help you just nail down that why of safety and how to troubleshoot it. Which, if you missed our why of safety, then check down in the description and there's a link to this whole series. And go ahead and hit that subscribe button and tap that bell. But on our basic safety system, we're going to have inputs. In this case, we have two e-stops, and we're going to have outputs, which in this case are these two contactors. And let's talk about the indicators when it is working properly. So we have a power fault, we have an in, and we have an out. And if we press the e-stop, both our in and our out drop out. Now, if we pull it back out, our in is going to be solid and our out is going to be flashing. And that tells us that our input circuit is good. Our output circuit is ready to go. It's just waiting on the reset. And we press the reset, and that's going to make that solid, pulls both our contactors in, and gives us light 2. Now, let's say we had a failure of one of these. In our previous video, we talked about that part of our typical safety relay is that there are two contacts. And in the case of this one, we're looking at S12, S22, S11, and S21. And we're going to hit those with a meter in a second. But what would happen if one of those fails? And so to simulate a failure, we have switch 1. Now, since they're normally closed contacts, and this is simulating a closed failure, it can't tell it until someone panics and hits the e-stop. So this machine is going to continue to run even though it does have a broken normally closed contact since it's broken the closed position. Now the operator panics and presses the e-stop. It does drop it out even though one contact has failed. And if we look at our inputs, the light's out, and our outputs, the light's out. Now we pull our e-stop back out, and notice we're not getting our input light. And so that tells us that the problem is somewhere in the input circuit. Compared to previously, we were in the same situation. The output light was flashing, letting us know it's somewhere in the output circuit. And finally, let's talk through one more scenario before we get the meter out. And that is if we have one of these contacts welded. So we're going to reset it again. This simulates this contact being welded. We press the e-stop. The inputs drop out. We pull it back out. We get our solid green input. So that tells us that our input circuit is good. Our output light is flashing. And when it's flashing, it's waiting on the reset. We press our reset and we get nothing. And that's because this button gets its power from this feedback circuit. It's the last item in the feedback circuit. And check out our video where we wired this to our PowerFlex 525 if you want some details on that. Now let's talk about how we can troubleshoot this with a meter. Because if you read the actual specs, these inputs are actually pulsing to check to make sure nobody's done any jumpering between these two circuits. And I think a lot of us, when we think something is pulsing, we're going to think we need some type of high frequency, counter, encoder, or something, some special meter to measure this. But if we look in Rockwell's manual, it actually gives us some strange voltage checks, but this is based off of those pulse frequencies. So on S21, it should be sending out roughly 18 volts, and S11 should be sending out roughly 14 volts with respect to A2. I take my T6-1000 and I put the black lead on A2 and I put the red lead on S11, then I am getting 14 volt. And if I go to S21, I get 18 volts. So that's pretty much the same thing they're showing there. So similarly, I should be able to check to S22, which is right beside of S11 on the back, and I have 18 volt, and to S21, I have 18 volt. So now we're going to make one of those contacts fail on this, and we're going to press our e-stop. Now, here is the most difficult part about troubleshooting safety circuits. So this is a question I bet you I asked 50 times on a training week. As I'll ask them, what is the purpose of a safety circuit? They're like, to protect the operator. So are we trying to make the machine run or trying to make the machine stop? And they're like, make the machine stop. So when we go to troubleshoot this, we got to remember that. We're not trying to make the machine run because we're broke down. We press the e-stop, pull it out, it won't reset. And here's what we end up doing. We're like, I need this machine to run. And if we check from A2 to S11, we have our 14 volt. S12, we got our 14 volt. S21, we got our 18 volt. And S22, we got our 18 volt. And we're going to sit there and be like, well, everything's there. Why won't the thing run? But here's what we have to remember. The purpose of the safety relay is to make sure the machine safely stops. Did it actually see the machine stop? No. And that's why we don't have our input here. So when we check this, you need to have the e-stop pressed. And in this case, from A2 to S11, we should have 14 volt. From A2 to S12, we should have 0 volts. From S21 to A2, we should have 18 volt. And from A2 to S22, we should have 0 volt. And that's how we would realize we have a stuck contact on our e-stop. So since it didn't see those break together, it's never going to let this machine run. All right, so the other one that we can end up in is a welded contact. So both contacts are energized, and this is going to make this contact fail. So you're going to see the gray pop out on this one. We press our e-stop. We saw this contact move. This one did not. We go to pull the e-stop back out, and it won't reset. And similarly to the other one, when we go out to work on the machine, we're always like, I need the machine to run. That's all we care about is the machine running. The idea that we need to know if the machine properly stopped, do you see how that can flip our whole thinking around? Because really, we're going to see our inputs here. It doesn't matter. You come to my class, y'all are going to examine this e-stop circuit to the nth degree, even though you have a good input. It happens every week. But on this output, you're just like, man, if this thing should be turning this output on as long as all this is good. But how does it know that it safely stopped the machine? Well, that is this feedback circuit right here. So the way that feedback circuit works, and like I told you earlier, check out that PowerFlex wiring video if you want to know some more, is we're going to take from our A2, well, actually we're going from our plus 24, but if we take a meter to our A2, from our A2 to one of our normally closed contacts, we have 24 volt. And it's going to have to see 24 volt through this whole circuit. Uh-oh, it doesn't see it. This contact right here is what feeds up to this button. So until you get power here, you're never going to have power on your reset. So the best thing to do in this case, if you don't feel you can reset it, is first of all, check your reset button. If you don't have power on the top of your reset or the side not going to your S34, then it's one of your devices throughout this loop. You're going to go find the device. We would see that we have a problem with it. We replace it. That's going to put power up on this button. So now we have 24 volt here going on up here, and all it's waiting on our operator to do now is press the e-stop. Now there is an Ethernet option for the standard safety relay. Honestly, I have never seen one, but I have seen the Ethernet used on the configurable safety relay a whole lot for diagnostics. So next we're going to talk about how you can diagnose the configurable safety relay, both through Connected Components Workbench and as adding it as a device in Studio 5000. And click here for a playlist including that.